So welcome to the another session of our Inequality and Poverty in Latin America course. Today we are really privileged to have Professor Francisco Ferreira from the London School of Economics, where he holds the Amartya Sen Professorship on Inequality Studies, and also he directs the International Inequalities Institute at the London School of Economics. And I say we're privileged because Professor Ferreira is one of the absolutely leading figures in the study of inequality globally. And today he's going to present his work on inequality of opportunity, a theme that he's been working now for many years, and made enormous contributions to the analysis of this very important topic. So, as usual, I have asked Professor Ferreira to share a little bit about himself with the group and with the audience. And then he will start the presentation, and the students can pose their Q&A in the Q&A section, and he will be able to respond to them, maybe if there are clarification during your lecture, you can ask, if not, towards the end. So the floor is yours. And again, many, many thanks for being with us today.
Thank you so much, Nora. Thank you to you and Ludovico for the invitation, and good morning. I think if most of you are in New Orleans, it's still good morning. So good morning to everyone. Pity I can't see you guys, but I'm going to hope you're there and can hear me. And if you can't hear me, or if anything goes wrong, please let us know, and we'll try and fix it. So yeah, so as Nora said, I now work at the LSE, which is also where I did my PhD in economics. I'm originally from Brazil, from São Paulo, which is actually where I am today. And I did my PhD in economics at LSE, spent many years, 24, 25 years at the World Bank, working mostly in the research, but also in some other places. And for a few years, I taught at the Catholic University in Rio and at the Paris School of Economics. And now I've been back at LSE for 4 years, just over 4 years, holding this chair, the Amartya Sen chair. And so today I'm going to try and share my screen here. It worked before. Let's hope it works now. So I will make this full screen. Can you see the full screen, Nora?
Yes, yeah. We can.
Great. Okay. So this lecture today is based on a paper that's part of the LACIR project, as you all know, because I know that there have been a number of them already. This one is on inequality of opportunity and intergenerational persistence in Latin America, with two of my co-authors, Paulo Brunori and Guido Neidhofer. And this slide here is probably not necessary for this audience, but just says a little bit about LACIR, the Latin American Caribbean Inequality Review. In fact, I was going to try to see if I could make this. I don't think it's going to work. So let's not try it. There's a way of making the pointer. Oh, there we go. All right, there we go. So yeah, the Latin American and Caribbean Inequality Review, which is a project that is now in its 4th or 5th year, and we have these 27 papers which have been now published in an open access journal called Oxford Open Economics, including 2 or 3 with Nora as a co-author, 3 I think, with Nora as a co-author. And you know, they focused on levels and trends in inequality, inequality of opportunity, inequality in markets, taxation, the role of the state, redistribution, and then issues of political inequality. And the paper that you're going to see today is sort of the introductory paper to this inequality of opportunity theme, which, as it says here, tries to look at the role of people's origins, you know, the family and communities from which people start, in shaping their outcomes and therefore the inequality in those outcomes. And so it's closely related to intergenerational mobility, as I'll show you in a moment. So that's the main question. The main question is, how strong is the transmission of socioeconomic status across generations in Latin America? That's what we try to set out to do. And we'll do that in the following way. So first I'll do a brief literature review, because obviously we are not the first people to ask that question. So many people have written about this before, and we try to summarize a little bit of that. That was, often the structure in the papers in this review, that we wanted to take stock of the state of the art and then sometimes propose new approaches of new ways of doing things. And I'll describe the one we're using in this paper, and talk about two different ways of looking at inequality of opportunity. Although for this talk, I'm going to focus on the ex ante one. Obviously, I'll describe the data and then at the end, make some comparisons both within Latin America and of Latin America with other parts of the world before concluding. Okay. I should say, by the way, that the paper has just come out. As you may know, Nora might have mentioned that the whole issue has just been published. But of course, it was written a couple of years ago. And so some of the things that are in this presentation, if you do look at the paper, some will be identical to what's in the paper. Some are newer because we were working actually on a revision of this for the Elsevier handbook on intergenerational mobility that Stephen Durlauf and Bash Mazumdar are editing. And so we have some new things which I've put in here as well. In case you don't see them in the paper, that's where they're coming from. Okay.
By the way, if I may, Chico, take the opportunity. We sent a message notifying the students that now all the papers are published in final version in the special issue of the OOE. And so that's that I just want to emphasize this, because now everybody can look at the final version of the papers in online.
Exactly. Thank you, Mara. So again, starting this literature review, the question, how can the degree of intergenerational persistence be quantified? Well, intergenerational persistence of what? So one of the first questions is, what is the main outcome, right, that's used in the literature? Intergenerational persistence of what? And, it could be of many things. In this presentation, I'll mostly look at income and education, okay? Of course, it could also be of wealth. It could be of occupation. And occupation, actually, there's a large sociological literature on occupation, which I am not attempting to do justice to here. We're really going to focus on the intergenerational transmission of income and education between families. And there are two main approaches, neither of which attempt to identify the causal effect of a particular thing. Both are descriptive of the extent to which there is this transmission. One is the intergenerational mobility literature, which I'll summarize, and the other is the inequality of opportunity literature. And the main difference is the intergenerational mobility literature looks at the association between the same variable for parents and children. So parents' income, children's income, parents' education, children's education. It looks at, a correlation, basically. There's a joint distribution, and it's looking at a bivariate association between those two things. Inequality of opportunity takes a slightly different angle, which is to say, okay, what if we take everything we can see that is inherited, that people are not responsible for because they're in their origins, to what extent can that predict future income? Okay. Now, before I start the review per se, I actually want to explore that which I just said, these two approaches and how they're related. And this presentation, I don't know all of your backgrounds. I assume many are economists, but this presentation is very light on equations. But there are a couple here, very simple ones, which you'll see. So I just wanted to bring to your attention what the relationship is between intergenerational mobility and inequality of opportunity. So as I said, IGM is often looking at how it is one outcome for parents correlated with the same outcome for children, whereas IOP is about, to what extent can inherited or predetermined factors predict incomes and therefore the current inequality in incomes. So, you know, these may seem quite different, but really they are actually very close. And here's what I want to show you. So here are two canonical equations, right? This one, which you probably have seen many times, is the Galtonian regression, children's income on parents' income, right? People often use this beta, which if these are in logs, this is the intergenerational elasticity, right? People use that as an inverse measure of mobility, as a measure of persistence. It has one little shortcoming, perhaps, which is it's affected by inequality in the margins, inequality in the parental income and the children's income. So it can be adjusted by these standard deviations of the parents' income and the children's income. And then you get the correlation coefficient. That's just the standard correlation coefficient between YC and YP. An alternative is one way of computing inequality of opportunity, one way amongst many, is to run a similar regression, but now it's a multivariate regression on a vector of circumstances that can include things like race, gender, where you were born, your parents' occupation, your parents' education, your family wealth when you were young, any number of things that you cannot yourself be held responsible for, but that you inherited. And to what extent can they predict YC? So we take then the inequality in the predicted income, just in the mathematical sense that, you know, they are alpha hat plus C times beta hat. And that inequality as a share of the total is a relative measure of inequality of opportunity. Now, what I want to point out is that they're actually quite close, because we know that in a simple regression like this, if you square the correlation coefficient, you got the R squared. And what's the R squared? Well, the R squared is the share in the variance of this that's predicted by the variance in the independent variable, right? So this is very much like an R squared. It's a share of inequality that is predicted, that is explained by the predicted variable. It's just that in this case, it may not be the variance. And the other difference is that instead of a single variable, you have many. But you can see that both of these things are really about the extent to which the inherited factors can predict the the outcome. Okay, and then a sort of what part of the variation in income, say, is predicted by those circumstances or by parental income in that case. This is not true for all measures of mobility, but it is for many that we're interested in, and so I just wanted to draw this analogy to your attention. So let me now then talk a little bit about what people have found in Latin America, typically looking first at education and then income. So I'm going to start with intergenerational mobility literature, education, income, then IOP literature, education, income, and that'll be fairly quick before I move into the newer approach. Okay, so the literature now is about 25 years old on intergenerational mobility of education in Latin America. Began often by work by Jerry Behrman and Miguel Zackley with others. There's a number of papers I mentioned here. On the whole, what that literature has found is that, particularly for older cohorts, the persistence, so that beta here, this is the beta, but now this is education, yeah? Children's education on parents' education measured by years of schooling. That beta was often between 0.5, 0.6, as we'll see in the next table, sometimes even higher. And this is quite a lot more than, say, for the US or Southern Europe, even, you know, which is around this range. And, you know, the ones for Northern Europe are even lower, okay? So here is a summary. You know, there's a lot of numbers. I'm going to draw attention to some specific numbers, but these are those betas, okay? And they are those betas for a range of Latin American countries. There are many studies, but over here we have them from five different studies. And in particular, we look at these two, which are quite recent, as you can see, and which have calculated them for a very wide range of countries, okay? So to draw your attention here, in green we have, focusing in particular at Neidhofer et al., in green we have the two lowest numbers. So you can see that the intergenerational regression coefficient in this case, not an elasticity because it's not logs, but intergenerational regression coefficient ranges from around 0.4, right, in Venezuela and Costa Rica, to over 0.6, almost 0.7 in El Salvador and Guatemala, which are the highest. And in between, you've got a large number of countries in the sort of 0.4 something, 0.5, almost getting to 0.6, okay? One interesting thing, for example, if you look at the Hertz study, which was a pioneering study, the numbers are even higher. And that in part is because he was looking at much younger cohorts. As we start looking at older cohorts, these numbers get smaller. And so this prompted people to conclude that intergenerational mobility might actually be getting a little bit better, at least for education in Latin America. And here we've got for 3 of those 5 studies, the first 3, we got estimates from country-specific data or from the Latino Barometro of these betas, but specifically for cohorts born in the 40s, 50s, 60s, 70s, and 80s. So these are taken from surveys much later, but they're looking at the intergenerational persistence for people born in those cohorts with respect to their parents. So people born in the 80s with respect to their parents, people born in the 40s with respect to their parents. And you see, you know, in some places it's not that pronounced. In Argentina, that's already down. But in many, many countries, you see a sort of downward sloping pattern. Very pronounced in Peru, Colombia, Brazil, right? Also present in Ecuador and so on. And as I said, people interpreted this as saying, well, look, maybe things are getting a little bit better, and you know, in one sense they are. But remember, this beta can be decomposed, as I said, into the true correlation coefficient and this ratio of standard deviations. And here is what you get from the Neidhofer et al. JDE paper. Here's what you get if you look at the rows. So here you've got the sort of average of those graphs. Yeah, you've got the average of those graphs. The betas are falling from this cohort in the 40s all the way down to the late 80s here. But the correlation coefficient and the rank correlation are remarkably stable at around 0.5. So for this to be true, either the inequality in the children's distribution of education is falling, or that one in the parents is rising. Right? So when we look at that, actually both things are happening. So here you've got the children. Okay, these are the cohorts, 1940s to 1980s. You've got the children here and the parents there, right? And so it's kind of interesting because, yeah, it turns out the betas are falling, but really it doesn't seem to reflect something about the association per se, the pure correlation coefficient. It seems to have something to do with the dynamics of current levels of inequality, where for the children's generation, it's falling, whereas for the parents, it's rising. Now, of course, you know, the parents of these guys who were born in the 1980s are like these guys, right? These guys are actually, these guys. So what we can do is we can take the parents and we can shift them by 30 years. And then you got this kind of interesting inverted U here, which is almost like an education Kuznets curve, if you like, where, you know, if these guys, they were born in the 1910s, right? The people who are the parents of the people born in the 1940s were born roughly 30 years earlier, approximately, right? So these are the parents of the kids born in the 1940s, but they were born in the 1910s. So I shift this curve to the left, and what you see is that there is actually this kind of dynamics here in the cross-sectional inequality. And this seems to be important to explain what's happening here with the betas. But the bad news is that the rows are fairly stable. So actually, there has been progress in the betas, but not in the association per se. Okay. So what about income? That's what I wanted to say in terms of a review of the literature on education, with some of our interpretation of that. What about income? Well, income is much harder because
Do
Yeah.
you mind saying, so what qualitatively, what that does it mean that the correlation seems to be very stable?
I think it means that the pure dependency, the pure transmission of status, right? So if you think of the joint distribution, that copula, the map, for example, the ranks, right? These are the rank, the triangles are the ranks. It says that your parents' rank in their distribution of education predicts half of your rank, right? So there's movement,
And it's been
but
stable.
and that's been completely stable. And in levels, the changes you see from the betas are really a consequence of these pattern of inequality in education. So the way I interpret this graph here is you think of an expansion in education, right? So here people had very little few years of schooling. Only an elite had completed high school. As time passes, more and more people finish primary school and high school and so on and enter university. And at some point, there's enough of them towards this upper end that inequality, which was first rising as a few people moved up, starts falling again as people catch up towards the ceiling of completed education. So this is a sort of, we looked at this, Nora, if you remember, and similar things in our work with Francois many years ago. I don't think we had such a nice picture of it, but there is this tendency going on, right? Yeah, does that answer the?
Yeah, I mean, I wanted to see what does it mean in terms also of the fluidity of education. So it means that people will have to expect to be 50% of the time in the same rank as their parents. So that's what I was also looking for.
Yeah, so for example, if we take the level is almost the same, right? So the correlation in levels is almost the same. And what a correlation of 0.5 says here is that you basically the regression coefficient, the interpretation people usually associate with the regression coefficient is if your parents' income or education is 20% above the mean, yours will be in expectation 10% above the mean, right? So this is the rate of regression to the mean. It's what a regression coefficient does. And so when the regression coefficient is smaller, the regression to the mean is faster, right? If it's 0.03, then your parents is 100% of the mean, you'll be 3% above the mean. So you're converging very quickly back to the mean on average. These high numbers mean that you're converging back to the mean very slowly. That is, there's a lot of persistence. Yeah. So let me move on then to the income part. So on the income part, that's actually, there are a number of studies and they find betas that are very large. So I was just saying what a beta means, right? So suppose, for example, here in Brazil, if Christopher Dunn was right in his estimate, this means that if your parents have an income that's twice the mean, you are still going to be 70% above the mean on average. If your parents are 50% of the mean, so they're half below the mean, then you're going to catch up only by a little bit. You're still going to be whatever 0.7 times 0.5 above that, right? So you can see what it means. It means convergence is very small, very slow. But the point is, there's actually, these numbers are hard to interpret because unlike in richer countries, we seldom have data that links parents to their adult children income that avoid co-residency bias. Because we don't have many sorts of data or data sources where we observe the incomes of children wherever they are living and parents wherever they're living and match together, typically we either observe the people who are still living with their parents, but those are obviously a selected sample, and that's what generates this co-residency bias, right? And so to avoid that, what people typically done in the past is to use this choose sample, choose stage least squares estimates, where you basically regress your parents. You go back to a sample, a survey of your parents' generation, regress income on their characteristics there, and use those coefficients on their characteristics in the sample today. I don't want to, get too bogged down on the methodology, but you can look up choose sample, choose stage least squares, and it's basically about importing the association between x's, between covariates that you observe today, importing the relationship between that and income from a survey of the time when the parents were in working age. So you can see it's a little more involved than if you observe both things. You're having to have basically an instrumental variable. You're having to have a first stage prediction that you then bring in, and this is what's happening here. Now, there are newer studies using administrative data, including for Brazil and Uruguay, which do much better than this. Because they are administrative data, tend to miss the informal sector, although both these studies make efforts to try to account for the informal sector, but they don't observe them. So there are issues with that as well. As a result of this, because in fact what we observe for the current generation are other parental characteristics that are not income, one way of dealing with this is to try and predict income using those characteristics, which is the choose sample, choose stage least squares. Another is to go directly to the inequality of opportunity literature, where we take a bunch of circumstances like, again, people's race, people's gender, their parents' occupation, their parents' education. And we try to see if you run a regression like that one that I showed you before, right? If you do this here, to what extent, can those circumstances predict YC? What is the ratio of the inequality measure in YC versus Y? And when we did this, I think the first study, not only for Latin America, but actually the first study for Latin America was one with Bourguignon, but one of the early studies on this is Ferreira, and we did with Jeremy Gignoux. Here, we found for income that these ratios ranged from about a quarter to about 36%, so just over a third in Guatemala. For consumption, they were even higher, so this is consumption expenditures. In Guatemala, you could explain almost a half of inequality measured by the mean log deviation. So inequality here is the mean log deviation, and that turns out to matter. In the later studies, we tend to use the Gini coefficient more, and I can explain in Q&A if you want why that is and what the differences are. But even for E0, which is not, is not the measure that captures this phenomenon the best, there were some fairly high numbers there. And there was also work doing this for education, although typically not for years of schooling, more for test scores, using data from PISA, where you have the test scores and you have inherited characteristics, and we try to estimate the share and the variance of test scores that were predicted by parental characteristics. And you can see that in the literature. But what I want to draw your attention to now, we're kind of halfway through our time, and I want to move to the new approaches. What I want to draw your attention to now is how in this study, for example, how we got to these numbers is we took the circumstances and in a more or less ad hoc way divided them. This is a very busy slide. There's a lot of stuff in it. I just want to explain very briefly, like what we did is we took ethnicity and then we broke it into two categories only, in different countries. Or we took father's occupation, for which we often have 11 or 20 variables, and we just said, okay, agricultural worker or domestic worker here or other here. Birth region, we did it into 3 categories. Why did we do that? Because we were afraid that if we, used all of this information and interacted it, we would overfit the model, basically. And it turns out we didn't quite, I can say that because I'm one of the authors, we didn't quite understand the maths of it, but we were intuitively on the right track. There's a problem if you do that. But on the other hand, what we did was ad hoc, right? What we did is we just kind of guessed, okay, let's take these 2 poor areas over here, or rich areas over here. No, these are the poor areas. Okay, here, this country I know well. So these are the rich areas in São Paulo and Federal District. then some mid-ranking areas, then some poorer areas, and you know that's your place of birth, and we divided it like that. We could have divided it in other ways. So there's something arbitrary about that. And so the new approach that we want to use for measuring IOP for income attempts to address this problem of selecting the partition. Okay. So now let me spend a moment or two just explaining these two different ways of measuring inequality of opportunity. This is a little on the nerdy side, so you know if you're not that interested in that, what we're really going to use is the ex ante. But the difference is as follows. You can, so equality of opportunity is basically about the following. You divide people, divide the population into groups that share the same circumstances. So one group, if there are only two circumstances with two variables each, so men, women, black, white, then there are four groups, okay? Obviously, if you see this number of circumstances here, there are going to be hundreds of groups, okay? Possibly thousands, as we'll see in a moment. And so one way is to say equality of opportunity is attained when all of those groups have the same average income. That means those circumstances were not predictive of average income, right? If all of those groups have the same average income, then whether you were born a black woman in the Northeast or a white man in the Southeast is not important in average terms. Deviations from this, so inequality in these means, is what is known in the literature as inequality in the smooth distribution, where people within each group are given their mean. And so we calculate that inequality. That will be inequality of opportunity in this ex ante way. Okay. An even more demanding requirement is, no, I don't want just the averages for all those groups to be the same. I want the entire distribution for those groups. So the conditional distribution of income on being in that type to be identical across types. Okay. And so that can be measured in some other way, which I won't bother you with here. But one of the things we do in this paper is to provide some nice new data-driven methods to calculate inequality of opportunity, both in this way and in this way. Since this is not a technical class on measurement of IOP, you know, if you're interested in this, you can see the references. But what I'm going to try to show you is that, you know, whichever way you do it, you get to numbers which are fairly similar to one another, although you learn different things by doing it in different ways. Whether you do it in this way or in this way, you need this partition. This capital pi here is the set of types, K and L, right? So you need a partition of the population into types. You need that, okay? Let me skip that. Now, how should we partition the population? So I showed you that ugly table that I had with Jeremy because I said we could have done it in different ways. This was pretty arbitrary the way we did it. We used some prior information we had about different ethnic groups, parental occupation, region. That was what we did. But you could, if you wanted to be, you know, if you wanted to use every possible combination, then you get into this kind of problem here. So I'm now going to talk about Bolivia as an example for the next few slides. In our data set for Bolivia in this paper, we had 5,265 observations that we could use, okay? We didn't have a lot of circumstances. We had sex, ethnicity, occupation of father of the mother, and we didn't need to even use both. We just used the highest, and education of the father and the mother, only in 4 categories each. Even with just this, you could have 2,400 types, right? So 2,400 types means, if you think in terms of a regression, if you think of a partition, if you think of a partition, it's a matrix of the population with 2,464 cells, into which you're going to try to fit 5,265 observations. If you think in terms of a regression, then this is the number of interactions, right? It's a regression of income on the interaction between these things. And you're trying to estimate each parameter with almost no degrees of freedom, right? So that leads to what econometricians call overfitting, okay? So that's the challenge. And that's why kind of we did something arbitrary. But in the face of that challenge, we can do better than just do something arbitrary. And I think, you know, what we've learned in the last few years in this literature is that when you're trying to measure inequality of opportunity, remember what this is about. It's really very simple. It's to use all the information you have about inherited stuff to see how much of current income it can predict. That's all you're doing. So it's about persistence, but instead of using income only, you're using everything you can observe, okay? You're basically facing two biases, okay? If you put too little stuff, you get a downward bias. And here's my little, I'm not sure this is very helpful, but basically, suppose you only had two observations in your data set, okay? You in your co-author looked and you said, I have 3 values for father's education, 3 values for mother's education. And so I've got these 9 types. And then your array, which is much better than you, went in and looked and says, oh, you also have gender, obviously. Okay, so we're going to now divide this into men and women. Okay, so obviously when you do that, this number can only go up. The inequality here can only go up, right? It'll stay the same as this if men and women have identical means for each of these cells. So long as they have different means, inequality in the smooth distribution will go up. Meaning to say, when you omit a circumstance, you're biasing your estimate of inequality of opportunity down. But if you put, and that's what we didn't know originally, and my co-author Paulo and his co-authors, Ferragine and Serlenga, showed formally that, of course, if you try to fit models with all of the things, you overfit. You know, you start predicting very well in sample, but under predicting out of sample, which is what happens when you overfit. So the solution to this, as typically in cases of prediction problems, is to let the data tell you what the optimal partition is, instead of doing making the arbitrary choices that we made. And you know, the recent, and even not even so recent, literature on machine learning provides you ways of doing that, because machine learning is all about prediction, really, right? It's all about using, given a certain data, you know, using the best, letting the data predict a certain variable in the best possible way. We use 2 of these methods, which were originally proposed by this guy Hawthorne and co-authors in different ways. It turns out, and this again goes on to the nerdy side, that the easiest way, the well-known way, which is conditional inference trees and random forests, they are designed to estimate features of the conditional distribution that focus on difference in means. So they are very much about this ex ante way, whereas there are these transformation trees which look at differences between quantile functions and are therefore well suited for this ex post stuff. But that's, you know, nice if you're into this, the nerdier side of this. I'm not going to spend much time on that. I'm going to focus, I'm going to show you some of these trees just because they're, you know, you do learn something from them. But what the big picture here is that the data-driven methods select a partition which is optimal in a well-defined statistical sense, which we show in the paper. The well-defined statistical sense is to minimize a loss function between these 2 biases, okay? So you're going to, in some sense, which is not necessarily the only sense, but in a well-defined sense, we're going to find a partition that gives us the best prediction that data is capable of giving us, balancing these upward and downward biases. Okay, that's what it's about. So it's about, given a data set, using a flexible statistical approach to model its distributional structure. So this, I'm going to leave it there, but blank and just listen to what I'm saying. What this says is how the conditional inference tree works. The way the conditional inference tree works is very simple. It has a Y variable and a bunch of C's, a bunch of circumstances: occupation, education of the parents, gender, place of birth, race. It looks for the one that is most highly correlated with Y. Let's say it's parents' education. Okay, pick that. Then it says, okay, but I can partition it in different ways. I can have this category versus the other 3. I can have this 2 versus the other 2, these 3 versus this 1, right? How do I partition it? The machine tries all of them and picks the division, which gives you the most significant statistical difference between the means of those 2 groups. So it does t-tests and picks the one with the lowest p-value, which is what this is about, okay? And then you got 2 nodes, and it does the same thing again. in each of the nodes and keeps doing them until you're no longer statistically significant at a predetermined critical value alpha, say 1%, 99% confidence level. Okay. It's actually, looking at this, it looks complicated, but it's just picking partitions by always looking what variable is most correlated with income here. This one, how do I split it so that I get the biggest statistical difference? Keep going until it's not significant anymore. And if you do it, and this is our data, but if we do it for Bolivia, this is what you've got. Okay, the data there interrupted my beautiful flow between the explanation and how it actually looks. But to tell you about the data, we have 27 household surveys for 9 countries. That's what we do in this paper that was published now as part of the last year. So here are the surveys we used for each of the 9 countries. Okay, that's what we've got. We've got Argentina, Bolivia, Brazil, Chile, Colombia, Ecuador, Guatemala, Panama, and Peru. Different numbers of years. In many cases, we have just one survey in this paper. In others, we have many more, like Peru. So I'll show you a little bit of time series for Peru and Chile, for example, later on. Okay. A unit of analysis is the individual. The income concept is age-adjusted equivalized household income. This matters, but in particular, I want you to bear in mind that it's household income. So when we look at gender, we got to remember that. Okay. We only work with household heads and spouses. All right. So here's the Bolivian tree for 2008. So let's look at this for a moment and see what we learn. So the first thing is that what the machine picked first was father's education, and greater than 2 means you went to university. So it first divided the Bolivian population into not people who went to university, that's very important, into people whose fathers went to university, okay? And then broke them up into, I believe, one of this one here is whites and smaller indigenous groups, and these are the Quechua and the Aymara, which are the biggest indigenous groups. Okay, these together, if you add their population shares, about 8% of the population in Bolivia. The other 92%, their parents did not go to university, their fathers did not go to university. And then when the machine looks what's most correlated with them, it was place of birth, rural and urban. If you know Bolivia, it should strike you as quite, sensible. So and then the rural guys are divided by ethnicity again into a group where the whites and smaller indigenous groups are, and another group. And so it keeps going, right? In some cases, quite a long chain. In others, not so much. And then what we actually want to do with this, I mean, the objective of this as a tool to estimate that share, to what extent can these characteristics predict income, is actually looking at this distribution here, right? Remember I said we were going to look at inequality in these means. Here are the means. Right? This is equality of opportunity. When they're not equal, to what extent are they unequal? So we're going to look at inequality just between these guys over here, all right, between these 10 groups. There are only 10 groups here. That's all we got. And we'll give everybody their mean. Okay, these numbers here show what share of the overall mean their mean is. This shows you the population share. And the Gini just between these 10 groups is 22. Which happens to be 45% of the total Gini in Bolivia. Now, we would never have guessed these interactions, right? If me and Jeremy were trying to guess them. That's the beauty of the machine, is it's picking the right interactions for you in the regression, okay? This is the richest group. This is the poorest group. You can do this for all of the countries we have. I don't want to take much time, but here's Bolivia, for example. So who are, excuse me, who are these guys? The poorest group here, who are numerous, right? They're 17% of the population. They earn on average just 40% of the mean, the total mean. Well, these guys are the poorest type. They're individuals born in a rural area with fathers have no formal education. Forget the translation. They have no formal education, 0 years of schooling. and they are basically indigenous of these main indigenous groups. They are 16% of the population. And here I can't see because on my screen there's something covering it, but you got their population share and income level and so on. The richest one was, as I said, fathers with, it's actually not secondary education or more, it's just tertiary. It's tertiary education. And they are whites or from these groups, okay? And, you know, you could do that for Argentina and Brazil and so on and so forth. And for Brazil, no, the richest type will be fathers and mothers had tertiary education. Again, this is wrong. It's tertiary education.
Sorry, minor thing, but you have, maybe, you know, it doesn't affect at all the results probably, but why do you have the Guaranis and the Chiquitanos in both groups? Shouldn't they be measured?
Because, yes, because they're different people, right? So these are Chiquitanos and Guaranis whose fathers had tertiary education. And these are the ones whose fathers had zero education. So they're different people. Why are they here? The people who are Guarani and Chiquitano who had tertiary education were in this data set, but they're probably like 2 or 3 of them. And what the machine found was that they actually grouped better with these guys than with the other ethnic group. Okay, but they're very small, and as you say, they really are going to make no real difference because there are very few of them. But you know that sometimes. So you can get, you know, a little bit of a sort of X-ray, if you like, of the society that you're looking at.
I am sorry, Chico, let me just be a little bit of a devil's advocate here. If I look at that, then I say, well, but I mean, you can be either from one indigenous group or non-indigenous. You're still in the richest type. So this circumstance doesn't seem to be disentangling whether you will be able to break the vicious cycle of intergenerational transmission or not. How would you respond?
Not if your parents went to university, if your fathers went to university.
So it is, if your fathers went to university, it doesn't matter if you belong to this group or.
So if your fathers went to university and you're here, there are probably going to be very few of these indigenous guys along with the whites, and they got grouped over here. And there are also some Quechuas and Aymaras, but you know, the numbers whose fathers went to university are tiny. Now, Nora, 2 things about that. In a moment, I'm going to show you how we compute the average importance of each of these circumstances. And I'm not going to show you today how we compute the marginal importance, but because you asked that question, I'll spend a moment when I get to the average. But the marginal comes exactly for very small groups. It turns out if you're a very small group, population size, the share of the population is very small, you know, there's a lot of noise around you and you may end up anywhere. And so then we can take a sort of the marginal effect of that in a different way using what's called a partial dependence plot, but it's analogous to a regression coefficient rather than a decomposition of the R squared. And then you get, you know, something a little clearer about them. Okay. All right, let me just go on. I mean, we could spend more time on this, but what I wanted to say was, you know, this is interesting, but in part what we were really doing it for was we wanted that share, right? This was just being used instead of a linear regression to compute that share of income inequality, in this case, the Gini, that can be explained by the circumstances, can be predicted by inherited stuff. And here it was 45%. Here's a table where we do this for all of the our countries. We have them for each wave. Here I'm just showing you the latest wave. So Peru, for example, we had many. I'm showing you only the latest. Okay, this is the number of types. It was 10 for Bolivia, but it can be more. Chile here has 29. Let me just check my battery real quick because yeah, I think I'm going to have to move. So just give me 1 second. Okay, so hopefully Christ is averted. Um, so here you've got the Toto genie. That's the Toto genie in Bolivia. Here, or in each of these countries. Here's that IOP genie. This is the genie for each tree. This is the genie, you know, amongst the means, the population weighted means of the nodes of the tree, the leaves of the tree. Right? So that's in some sense the share, you know, the genie just in predicted incomes. Here is this. Here is this over that. So I think here's this over that, sorry. So this is the shares. I just said it was 45 for Bolivia. On average, it's 48. Now, what are these forests? Well, it turns out, again, nerdy parentheses, but just very briefly, these trees here, they're nice, you know, they're informative. They are shown in the statistical theory to be unbiased estimators, but they're high variance estimators, meaning change the sample a little bit, and what variable is at the top here can change. So what the forest does, in very simple terms, is it takes an average of many trees. Okay, so it does little, basically kind of a bootstrapping. It selects subsamples of the sample, changes some circumstances, and in a well-defined way, tries to take an average of the tree. So these are the more robust estimates, if you like. And just to draw your attention here to two examples, Brazil, where I am now, between the 25 types that are the nodes of our tree, we got a Gini of 30, which is about 60%, almost, right? 59%, both in the tree and in the forest of the total. And on average for Latin America, we just get about 50%. Okay, let me ignore the memo item here. So
Just
this, in a
moment.
sense,
Sorry, I mean, Guatemala looks strange that it's on the lower end because
I agree. This is the thing with giving this talk to experts that know the region very well. That's right. Guatemala 2011 is odd. We have another year for Guatemala, I believe. And in that year, where's Guatemala? Yeah, in 2006, it's much higher. So there's something about the 2011 sample which is different. But we were being consistent here. We wanted to use the latest year, and so Guatemala is that. Now there are issues. For example, there's a paper I saw in January in a little winter school in the Dolomites in Italy of somebody that took the Colombia 2010 and showed that our Colombia 2010, they get the same results as we do, but again, find that 2010 is actually sort of a lower inequality year for Colombia markedly. So, there are issues with the sampling and the surveys that one has to be aware of. Okay. So here now, just a bunch of I think we're moving towards
If you allow me just a teaching moment, the caveat is important because for users of this information, then they have to be careful that things do not necessarily have to be taken just because they're there. One has to think about the context, and some of the indicators may not be consistent with one's ex ante expectation, and be more sort of prudent about making statements. No?
Absolutely right. And also, it means that the way research is done is never take what people who came before you said as the absolute truth. Probe, always probe. And what these guys did in did the paper. They actually did that paper because, like Nora noticed about Guatemala, they noticed our result for Colombia and thought it was too low, and found that we had picked a year, unwittingly picked a year that was particularly low. Okay, moving along. The earlier paper that I showed you, the Ferreira-Ginhoul one, which had lower numbers, used the mean log deviation. This paper uses the Gini. Okay, the reason for that primarily is that the mean log deviation is particularly sensitive to the bottom of the distribution, to a tail. And because it's sensitive to a tail, and when you're taking group averages, the central limit theorem means you are bringing the distribution towards the middle, and it's not sensitive to the middle, whereas the Gini is sensitive to the middle. Now, the Gini has decomposability properties that are worse, which is why we initially used the MLD. But and I can go back to this in discussion, we're very confident that the numbers we're using are the best available numbers at the moment, because the residual of the Gini decomposition is always positive. So if there's some between type in there, these numbers would be even higher. Okay, these shares would be even higher. In any case, the two are very closely correlated. If you see here, the correlation between the shares in MLD and in Gini are 0.97 in this sample, although the levels are different if you see the scale. Yeah. So the information they contain in terms of ranking countries, or even in the level correlations, are very close. Here are some time series, so you can sort of look at the random forest and the tree. You can see that they behave quite well in Peru. There's a gap here in 2009 in Chile, and so on. Here is the thing I told Nora I would talk a little bit about. This is a decomposition. It's a Shapley value decomposition, and I don't have time to explain what that does, but it's the appropriate way of taking the individual contribution of each circumstance to the total. Okay, so in a purely descriptive sense, all of those circumstances together give you these kinds of inequality. How important is each circumstance on average? And the Shapley value decomposition allows us to say something about that. And what I want to highlight is that in most countries, these bottom three things, which is family background, mother's education, father's education, and the highest parental occupation, tend to be by far the most important. Bolivia is actually where they are least important, because place of birth and ethnicity matter a lot in Bolivia. Sex matters very little here, but that is because, as this thing says here, because we're looking at equivalized household income. So it's nothing, any within household inequality is ignored. Any earnings inequality between men and women is ignored. We're looking cross family. So this little importance of gender only reflects differences in household composition between single men and single women.
I have
but
a methodological question here. If education is highly determined by ethnicity, how do you take care of that indirect impact of ethnicity on your outcomes here?
It's an excellent question, and it's also one you've asked me before, that you may not remember, but you've asked me this in the LACIR project as well. It's a very consistent and right concern, and I get it from other people as well. So this is why I said this is a descriptive decomposition of how important as predictors they are. It is not a structural model. So if you wrote a model in which the occupation of people generations in the past was shaped by their race, which would surely be the right model, right? Then race would be much more important. And this is not what is done here, because I don't know how to write that structural model. I don't know that anyone does. These things are deeply intertwined. Occupation reflects education, right? So this is simply, in a predictive sense, what do you get? Okay. All right, let me move along, because I think, how much time do I have, Nora? Negative something?
Say about 3 more minutes.
3 more minutes. Okay, that's good. So let me skip the ex post. The ex post, I'll just say this is the tree for Bolivia for the ex post. Okay. So this here, we're looking for differences in the entire distribution rather than just the mean. It doesn't, the algorithm looks different. The differences are not enormous, but for example, now birth area is the highest thing rather than father's education. Okay, and ethnicity is still enormously important. That allows us to predict the CDF of each type. So here you end up with not 10, but 11 groups. And this method allows us to see the conditional distribution function for each of the types. And the way we compute inequality in this case is not the inequality between means, but it's at each quantile, we take the inequality and then we take an average, okay, basically. So it's slightly different. And even though it's slightly different, the numbers are not gigantically different. Before this was 45, now it's 49. Over here, the average before was, for ex ante, the average was 245 with a ratio of 0.5. And now this is 255 with a ratio of 0.52. There's we find, not only in Latin America, but elsewhere, we find that there tend to be a few more types in the ex post, and the inequality numbers are a little larger, but not very much, and the correlation is very strong. You can do the same thing here for that, for the ex post. The differences, as you can see, are not too pronounced. The family background variables, education and occupation of the parents, are still the most important. Well, you might say, well, if it's that similar, why bother doing both? And I have a reason, which I won't have time to tell you, but you do learn something different from them. And that's basically when types have similar means, but different conditional distributions. You learn something by doing it by the conditional distribution rather than the mean. To conclude, I just want to give you some comparisons. So here, for all of our, for a number of our data sets, maybe all of them, yeah, maybe all of them, I have our two estimates, ex ante and ex post for the Gini, compared to the row squares for the education regression, so that mobility regression that I showed you before, but using our data, and then an approximate row square for income, which is not using our data, but using the studies that are listed here. Okay, the point being that with the exception of this one Ecuador estimate here, where you have a correlation coefficient higher than 1, and as you know, a correlation coefficient cannot be higher than 1. But this is the estimate that you get from that particular study. So it's clearly something a little exaggerated in that study. Actually, we find, a share of income today, of inequality today, that is predicted by inherited circumstances, which is considerably higher than looking just at the intergenerational mobility estimates from education or income. One caveat is this is the Gini, and these are variances. So part of the difference is that. The other thing is, in the case of the purple bars, this is education, is not income, right? This is income. But they're very large, and they're in the range of 0.5 to 0.6, so 50 to 60% of total inequality in Latin America can be accounted for, even in these samples, using this method, by inherited circumstances. Here's a comparison, and I'm now very nearly at the end, Ludovico. This is a comparison across countries. So we've created this GEOM database, this global estimates of opportunity and mobility, which you can get. The ECINEC, the Society for the Study of Economic Inequality, of which Nora is currently the president, is the host of this. So if you type www.geom.ecinec or @ecinec or something like that, you'll find .ecinec. You'll find these data. But these are, we have 70-something countries. These countries are in consumption. They use consumption, so they're on to one side here. These all use income, and Latin America is the blue. So you can see that these shares that we were looking at are very high in Latin America relative to everywhere else except South Africa. Okay, so this one here is South Africa. But Latin America tends to have not only high inequality, as you've heard from many others in this course, but very high degrees of persistence of inequality across generations. Okay, Let me end there, maybe. Did this just to say this is a Great Gatsby curve, which you may or may not have seen. A Great Gatsby curve was originally proposed by Miles Korak using intergenerational mobility or intergenerational persistence, 1 minus intergenerational mobility, on this axis and inequality on this axis. He only had a few countries in the beginning, but he found this positive association that suggests that the higher the level of inequality, the lower the level of mobility, the higher the level of persistence. As I've tried to convince you in the beginning, inequality of opportunity is conceptually closely related to intergenerational mobility. And indeed, we find the same upward sloping relationship. And here I've put the Latin American countries here as well. So we tend to have high levels of inequality and high levels of persistence in the global case. So let me stop there. Thank you very much. I'll stop sharing.
Thanks very much for this very comprehensive presentation on a topic that technically is quite complex. I think that that's one important thing for people to realize, how important it is to get the right gauge, the right indicator to assess the extent to which circumstances determine outcomes. And I think what you conveyed today is that if you use the traditional intergenerational mobility indicators, you may be underestimating significantly the extent to which circumstances play a role. And even though you have identified that parents' education and occupation seem to be the main drivers, like we discussed, these are the decomposition, description, and the causal factors may run deeper and may be associated as well to ethnicity and race. So thanks. I hope that I conveyed this message. Okay, great. So now I think we have a question, but Ludovico will handle the Q&A.
We have 2 questions. The first, with the emerging Black middle class educated in Brazil, specifically in the 21st century, would we expect these trends to continue for Afro-Brazilians? And there's
That's
also...
Sorry.
No, I was just going to say that this student wants to know if you taught Marielle Franco at the university in Rio.
No, I didn't teach Marielle Franco at the university in Rio. So I would have loved to, but no. No, it's a very good question. You know, I need to look at some newer data than the latest data that I've looked at, which is, in this case, it's 2014. But when I did, when last I looked at the ranking of types in Brazil, so from the poorest to the richest, the poorest were all, they had other different characteristics, but they were all Black or mixed race. So, you know, in the terminology used by the Brazilian Statistical Institute, pretos ou pardos, which is over 50% of the population. So there was incredible persistence. There's another presentation I give where I put a picture of a plantation, a sugarcane plantation in Brazil, with the Black slaves taking care of the white owners' children, and then I put the ranking of types in the 1990s, and the people who do worst are not only Black, but their parents were agricultural workers for the bottom 10% of the population. So the degree of persistence that you get from slavery, is dramatic. And this goes to Nora's earlier point about, not only race, but race as race in a context of institutionalized exploitation and racism and so on, have huge historical persistence. And just as a plug, there's another paper in this series by Felipe Valencia and Francisco Eslava, which is also in the book, where they look at the persistence of the explanatory power, not of race, but of the institutions of slavery, and also in Spanish America of indigenous exploitation. He presented it already. Okay, well, so you know it. Okay. So just to conclude, so I don't want to sound too negative, because the more recent data may be different, and I just haven't looked at it. It is quite possible that there is a rising black middle class. So there will be my sense, but this is now a hunch, a hypothesis, is that we will start seeing some black people with more educated parents moving up in that types distribution, but at the very bottom, you're still going to have a lot of black people. That's my sense.
Thank you. The second question is, in your paper, you discuss how intergenerational transmission of socioeconomic status is particularly strong in Latin America. Significant variation, not just between urban and rural areas, but rather within urban regions. Beyond differences in public versus private education and job market segmentation, what other factors might explain these intra-urban disparities in equality of opportunity?
That's an excellent question. I think you already mentioned some of the answers there. So labor market issues, not only segmentation, but potentially discrimination is also important. And, the division of schools into public and private schooling, also very important. And I don't know, Nora, if Raquel has already presented in your series.
He was not able, so we don't have gender.
No, but education as well, right? She also did the education.
No, we had Miguel Sekeli present education.
Oh, okay. So there you would have seen, if you go back to Miguel's presentation, almost certainly you would have seen the big premium of private schools, which is, perhaps why we're asking that question is very, very much there. What other factors do you say? Let me make one specific and one more general answer. A specific one is that the other thing that Latin America is fairly unique about, two things. One is unusually high rates of return to education. So it's not only that there are differences in levels of education, but if there is a difference between, say, completing secondary school and completing tertiary school, right? The same difference in Scandinavia or Latin America will translate into much larger income gaps in Latin America than in Scandinavia. And I think this is true even in just the labor incomes prior to redistribution. So there are very big returns to education in Latin America, which amplify the disadvantages in terms of education. The other thing we have quite a lot of, most countries do, but Latin America is very high, is assortative mating. So we tend to marry people with similar levels of education, or sociologists would say similar class backgrounds, right? We are very segmented societies. We go to different schools, we go to different universities, we work in different places. We marry people from similar backgrounds, and that further exacerbates intergenerational transmission. This is true anywhere, but the statistics that are out there in terms of correlation coefficients of spousal levels of education suggest it's higher in Latin America than in most other places. And then the more general remark is, the family has enormous power in transmitting advantage. It operates through genes, possibly. It operates through the conditions in early childhood at home. It operates through the neighborhoods you choose to live in. It operates through the schools you put your children in. It operates through the peers in those schools, to the fact that the teachers' quality is correlated with the income of the parents. And then it operates through the fact that people with better education end up working for bigger companies that are able to pay more. So there's also papers in LACIR about inequality amongst our firms, amongst the productive, about companies. And so the matching of workers to companies further exacerbates this, and it's part of the reason for that very high education premium that I talked about. So there's a whole system, and I'm not suggesting somebody sat down and designed the system, but it is the system that has evolved over time, possibly from these very unequal origins, and which still, has a cumulative effect, in which there's different pieces: whom you marry, where you go to school, the returns to school, the job you go to. These are part of the cycles of reproduction of inequality that we try to understand through this review. And they, I think, provide a bigger picture answer to your question.
Perfect timing. We're at the end of our period. Thank you so much, Francisco, not only for your excellent presentation, but also for situating it in the context of the larger publication.